Can you see the screen?
Yes, sir.
Okay. Now the next theorem is let phi be the any solution of L of y. Okay, which is nth order homogeneous differential equation containing the points naught into e raised to minus k into mod of x minus x naught, which is less than norm of phi of x, which is less than or equal to e raised to k into mod of x minus x naught into norm of phi of x naught. Okay, where k is nothing but 1 plus mod a1 plus mod a2 up to mod an, and phi of x is nothing but norm of phi of x is equal to mod of phi of x square plus mod of phi dash of x bracket square up to so on mod of phi raised to n minus 1 x bracket square and whole bracket raised to 1 by 2. Okay, तिथे second order ला होता, इथे nth order ला. Okay, now look at here the proof of this theorem. Proof. Okay, let u of x is equal to, again similar process, norm of phi of x bracket square. Okay, give it as an equation number 1, which is equal to what is what it is phi of x mod of phi of x bracket square plus mod of phi dash of x bracket square up to so on mod of phi raised to n minus 1 of x bracket square and whole bracket raised to 1 by 2. Okay, इथे स्क्वेअर असल्यामुळे काय होणार 1 by 2 येणार नाही. ओके, स्क्वेअर असल्यामुळे हा 1 by 2 तुमचा येणार नाही. ओके, एनी डाउट अप टू हियर?
No, sir.
Now, where u is equal to, that is u of x, that is u is equal to, okay, what is the phi dash phi of x bracket square, mod of phi of x bracket square is nothing but, give it as equation number 1. Okay, this is the equation number 1. And what is the mod of phi of x bracket square? Look at it, phi into phi dash plus what is the mod of phi dash of x? Phi dash into phi dash bar. Okay, similarly up to so on n times, n minus 1 times. Okay, this is phi raised to n minus 1 into phi raised to n minus 1 bar. Since mod z square is equal to z into z bar, this property we used here. Okay, any doubt? Give it
No,
as an
sir.
2. Now differentiate with respect to x, we get x, we get, नीट लक्ष द्या, कॅल्क्युलेशन महत्वाचं आहे बघा, which is equal to u dash. Okay, instead of u of x we write only u. Okay, so u dash is equal to, first as it is derivative of second plus second as it is derivative of first. Okay, plus now here first as it is derivative of second plus second as it is derivative of first. Okay, up to so on n times. शेवटची टर्म काय येणार तुमची phi raised to n minus 1 into phi dash phi bar of nth derivative of phi plus phi raised to n into phi bar n minus 1. Okay, phi raised to n minus 1 bar. Okay, ही तुमची शेवटची टर्म येणार ह्याचा डेरिव्हेटिव्ह. Okay, now look at here, taking modulus on both sides, what we get, taking modulus on both sides, we get u dash mod of u dash is equal to ओके, तुमचा इथे एवढे ह्या मॉड घेतल्यानंतर काय ना पुन्हा स्टेप लिहायची गरज नाही का. ओके, इथंच लिहा तुम्ही मॉड. Okay, so now taking modulus on both sides, we get this term again. Now u dash is less than or equal to what we have then phi bar mod of phi into mod of phi dash of bar plus mod of phi bar into mod of phi dash plus. ओके, कळते ना कसं येतं हे. मॉड ऑफ फाय डॅश इंटू मॉड ऑफ फाय डबल डॅश बार प्लस मॉड ऑफ फाय डॅश ऑफ बार इंटू मॉड ऑफ फाय डबल डॅश प्लस अप टू सो ऑन mod of phi raised to n minus 1 into mod of phi n bar plus mod of phi n plus mod of, sorry, into here. Okay, the into mod of y raised to n minus 1 bar. Okay, why? Because mod of a plus b is less than or equal to mod a plus mod b using this property here. Okay, ही property use करून इथे काय येणार, less than or equal to. Any doubt up to here?
No, sir.
Since and mod of a dot b is equal to mod of a into mod of b. Using these two property, we get this two. Okay, which is equal to u dash is less than mod of u dash is less than 2 times. Okay, नीट लक्ष द्या, इथे काय येणार, mod of z bar, mod of z bar is equal to काय येणार, mod of z. Okay, so instead of here phi dash bar we can write only phi bar. Sorry, leave it, थांबा, step clear कर. Look at here, this is mod of phi into mod of phi dash. Okay, plus हा बार जाणार, का जाणार, बिकॉज सिन्स mod of z bar is equal to mod z. Okay, using this property here, instead of this we can write only phi dash. Similarly here, phi mod of phi into mod of phi dash plus mod of phi dash into mod of phi double dash. Okay, हा बार तुमचा जाणार वरच्या डोक्यावरचा, because using this property. Okay, plus mod of phi dash into mod of phi double dash plus up to so on plus mod of phi raised to n minus 1 into mod of phi n into plus mod of phi raised to n into mod of phi raised to n minus 1. Okay, any doubt? Any
No,
doubt
sir.
है? Okay, so hence we get mod of u dash is less than or equal to 2 times mod of phi into mod of phi dash. Okay, 2 times this is ह्या दोघांची व्हॅल्यू इथे येणार. ओके, up to so on plus 2 times mod of phi raised to n minus 1 into phi raised to n, mod of phi raised to n. Okay, any doubt up to here?
No, sir.
Wait a minute. But as phi is solution of, we get L of phi is equal to 0. Okay, but what is L of y? Here phi raised to n, that is, which implies phi raised to n plus a1 phi raised to n minus 1 plus a2 phi raised to n minus 2 plus up to so on an phi, which is equal to 0. which implies phi raised to n, which is equal to minus sign in the bracket a1, okay, pi raised to n minus 1 plus a2 pi raised to n minus 2 up to so on plus an pi. Okay, any doubt up to here?
No, sir.
Okay, now wait a minute. हे तुमचं इक्वेशन 1, हे इक्वेशन नंबर 2. Okay, equation 3 ह्याला give it is in equation number 3, and this is equation number 4. Now put the value of 4 in equation number 3. इथे ठेवायचं. Okay, mod of this one. So what we get here? Look at here. Implies mod of phi raised to n is equal to, here we get mod of a1 into, okay, calculationचा पार्ट असल्यामुळे याच्यात एक्सप्लेन करण्यात. Okay, here we get mod of minus sign जाणार तुमचा mod घेतल्यानंतर a1 phi raised to n minus 1 plus a2 phi raised to n minus 2 up to so on an pi. Okay, this is in the mod. So putting the value hella 4 mod. So putting the value of 4 in equation number 3. So what we get here? Look at it. Mod of u dash is less than or equal to, okay, 2 into this term as it is, pi into pi dash plus 2 into pi dash into pi double dash, okay, plus up to so on 2 into mod of phi raised to n minus 1. Now what is the mod of phi n? This one, okay, he term into a1 pi raised to n minus 1 plus a2 pi raised to n minus 2 plus up to so on. Any doubt up to here? काही doubt आहेत का इथपर्यंत?
No, sir.
Which implies लिहून घेत जा म्हणजे कळेल तुम्हाला. Mod of u dash is less than or equal to, okay, this term whole term as it is, mod of phi into phi dash plus 2 times mod of phi dash into mod of phi double dash. Okay, plus into mod of a1 into mod of pi raised to n minus 1 bracket g first term. Okay, plus नीट लक्ष द्या, हे 2 into mod a2, 2 into mod a2. ओके, इथे लेस दॅन ऑर इक्वल टू आहे म्हणजे म्हणल्यानंतर ही टर्म जी असेल ती ह्याच्यापेक्षा मोठी असेल. ओके, आपण जी खाली टर्म लिहितोय ती ह्याच्यापेक्षा काय असणार? मोठीच असणार. सो देर इज नो इफेक्ट ऑन this sign less than or equal to. Okay, so here we get 2 into mod a2 into mod of phi raised to n minus 1 into mod of phi raised to n minus 2. Okay, प्रत्येक टर्मला मल्टिप्लाय करा. Okay, any doubt up to here?
No,
Plus
sir.
2 so on, we get 2 into mod an into mod of phi raised to n minus 1 into mod of pi. Okay, any doubt? Give it as an equation number 5. Okay, but we know that 2 into mod b into mod c, we proved in the previous lecture this one, okay, is less than or equal to mod b square plus mod c square. So using this relation in the equation 5, we get then mod of, it implies mod of u dash is less than or equal to, okay, instead of this two one, we can write here mod of phi plus, sorry, mod of phi square plus mod of phi dash bracket square. Okay, plus, instead of these two, we can write mod of phi dash of square plus mod of phi double dash square. Okay, any doubt?
No, sir.
Plus up to so on. Plus. Okay, इथे काय येणार आता ही टर्म्स ॲज इट इज येणार. ओके, 2 into mod of a1 into this term. Okay, as it is येणार. Mod of y raised to n minus 1. Okay, bracket square plus now this mod a2 as it is. ओके, ही टर्म काहीच चेंज होणार नाही, ही आहे असं असं राहणार फक्त. या टर्ममध्ये काय येणार mod a2 as it is, and instead of these two apply this property here. So here we get in the bracket mod of phi raised to n minus 1 bracket square plus mod of phi raised to n minus 2 whole bracket square. Okay, any doubt? Plus
No, sir.
and apply this for these two one, mod raised phi raised to n minus 1 into mod of phi. So this is mod a n as it is here into whole bracket mod of phi raised to n minus 1 bracket square. Okay, plus mod of phi of square. Okay, any doubt?
No, sir.
So hence we get, it implies that mod of u dash is less than or equal to. ओके, आता नीट लक्ष द्यायचं काय. आता मी काय कॉमेंट करतो, इथे फाय mod of phi square is there. Okay, here the mod of phi square is there, and here the mod of phi square is there. Okay, so take this common. So here in the bracket we get 1 plus mod an into bracket phi square mod of phi square. ओके, त्याच्यातनं ही टर्म कॉमन काढली, राहिला काय आतमध्ये 1 प्लस मॉड एन हा एका ब्रॅकेटमध्ये इंटू फाय स्क्वेअर. ओके, एनी डाऊट? प्लस आता इथे लक्ष द्या, इथे एक फाय डॅश स्क्वेअर आहे, इथे एक फाय डॅश स्क्वेअर आहे, किती झाले 2 फाय डॅश स्क्वेअर. सो राईट 2 प्लस मॉड ऑफ an मायनस 1. ओके, एन मायनस 1 कुठून आला, ह्याच्या आधीच्या टर्म मध्ये काय असणार, इथे जर फाय असेल तर ह्याच्या आधीच्या टर्म मध्ये काय असणार, इथे एन मायनस 1 असणार ना कुठेतरी, इंटू असणार. इथे ही टर्म पण असणार कुठली, फाय डॅशची टर्म. इथे जर फायची टर्म असेल, ओके, फायची टर्म काय काय होते इथे, कमी कमी होत चालले, एन मायनस 2 आहे. ओके, आधी एन मायनस 1 होता, आधी आता एन मायनस 2 झाला, एन मायनस 3 असं करत करत कुठे आलाय तो फाय पर्यंत आलाय. मग ह्याच्या आधीच्या टर्म मध्ये कुठेतरी फाय डॅश असणार. So here we get 2 plus mod of an minus 1 in one bracket into mod of phi dash of square. Okay, any doubt?
No, sir.
In general आपण लिहितो मग घोळ होईल थोडा. ओके, सिमिलरली प्लस 2 into bracket, in the bracket 2 plus mod of an minus 2 bracket complete with mod of phi double dash bracket square we get. Okay, सॉल्व केल्यानंतर ही प्लस अप टू सो ऑन. हियर वी गेट the bracket 2 plus mod of a2, okay, into pi raised to n minus 2, n minus 2 bracket square. ओके, इथे 1 असताना इथे फाय डॅश येतोय, इथे 2 असताना फाय डबल डॅश येतोय. ओके, सो इथे 2 असताना काय येणार n मायनस 2 डेरिव्हेटिव्ह. ओके, कळते का कसं इन जनरलायझेशन करायचं. ओके, एन मायनस 0 असताना 0 डेरिव्हेटिव्ह, एन मायनस 1 असताना 1 डेरिव्हेटिव्ह आहे, एन मायनस 2 असताना सेकंड डेरिव्हेटिव्ह आहे. सो हियर ए टू ला काय येणार मग एन मायनस 2. ओके, प्लस up to so on. Here we get in the bracket 1 plus 2 mod a1 plus mod a2 up to so on plus mod an in the bracket phi raised to n minus 1 mod of phi raised to n minus 1 bracket square. ओके, हे कसं आलं नीट लक्षात द्यायचं. ह्याच्यातनं काय कॉमन काढलंय फाय रेस टू एन मायनस वन. सो हिअर वी गेट 2 इंटू मॉड ए वन हिअर. इथे काय आलं तुमचं 2 इंटू मॉड ए. ओके, ह्याच्यातनं काय कॉमन काढलंय आपण फाय रेस टू एन मायनस वन ब्रॅकेट स्क्वेअर कॉमन. सो आत काय झालं इथे मॉड ए टू. ओके, अप टू सो ऑन इथे काय कॉमन काढला मॉड ए एन हा इथं आला आणि हा फाय रेस टू एन मायनस वन इकडे. ओके, कॉमन काढल्यानंतर एनी डाऊट अप टू हिअर. कळते ना काय चालू आहे.
हो सर.
ओके, फक्त सिम्प्लिफिकेशन करत जायचं आहे. नाव लुक एट हिअर. सिन्स आपल्याला टर्म काय ऍडजस्ट करायचे, के ची व्हॅल्यू काय ऍडजस्ट करायची. लुक एट हिअर. हिअर वी हॅव के इज इक्वल टू 1 प्लस मॉड a1 प्लस अप टू सो ऑन मॉड an. ओके, सिन्स since each coefficient each coefficient of RHS right hand side is less than or equal to 2k, where k is equal to what 1 plus mod a1 plus mod a2 plus up to so on mod an. Okay, so by adding ही तुमची प्रत्येक टर्म जी कुठली टर्म 1 प्लस ए एन 2 प्लस ए एन मायनस वन मॉड ए एन मायनस वन 2 प्लस मॉड ए एन मायनस टू यातली प्रत्येक टर्म इच कोएफिशिएंट काय तुमची लेस देन 2k, वेर के इज इक्वल टू व्हॉट दिस वन. ओके, के इज इक्वल टू 1 प्लस मॉड ए वन प्लस मॉड अप टू मॉड ए एन. त्यातली प्रत्येक टर्म प्रत्येक कोएफिशिएंट काय तुमचा के पेक्षा छोटा आहे. त्यातला प्रत्येक कोएफिशिएंट हा के पेक्षा छोटा आहे. हा okay, this one, okay, and this one, all these coefficient is less than 2k. Okay, hence by adding some positive quantity on right hand side, on right hand side we can convert the coefficient of each term, coefficient to each term as 2k. Okay, hence there is no effect on this less than or equal to sign. ही तुमची दिलेली व्हॅल्यू काय असणार ऑलवेज आधीपासूनच तुमची लेस दॅन ऑर इक्वल टू आहे. ओके, ऑलरेडी since by adding some positive quantity on the right hand side, so this all this coefficient we convert to a as 2k. ओके, तुमचा 2k हा प्रत्येक कोएफिशिएंट पेक्षा कसा आहे मोठा आहे. त्यामुळे मी जर असे टर्म ऍडजस्ट करणार प्रत्येकाचा कोएफिशिएंट किती यायला पाहिजे 2k. Hence there is no effect on this side, this sign. Okay, less than or equal to. Hence we get u dash mod of u dash is less than or equal to, this is 2k into mod of phi of square, phi square plus 2k into mod of phi dash of square. Similarly up to so on plus 2k into mod of phi raised to n minus 1 bracket square. Okay, any doubt up to here? काही डाउट्स आहेत का याच्यापर्यंत?
नो सर.
ओके, कळतंय व्यवस्थित. Hence which is less than or equal to 2k take as a common. So in the bracket we get mod of phi square plus mod of phi dash of square up to so on plus mod of phi raised to n minus 1 bracket square. Okay, this is the u dash. Okay, which implies that mod of u dash is less than or equal to 2k into, this is nothing but what is the value of this one, u of x. Okay, this is the value of u of x. U of x is nothing but what? This one. Okay, हे काय तुमचं u of x आहे ना? Okay. So hence we get u dash of x is less than or equal to 2k into u of x, which implies that if suppose mod x is less than or equal to a, what it means? X in between a and
Plus A and minus A.
okay, it implies that minus 2k is less into u of x is less than or equal to u dash of x, which is less than or equal to 2k into u of x. Okay, give it as an equation number 6. Okay, any doubt? 5 कुठे झाला? हा तुमचा 5 हा equation number 6. Okay, now consider the right up of the above inequality. Right up of the above inequality. Okay, so what we get? U dash of x is less than or equal to 2k into u of x. Okay, which implies u dash of x upon u of x, which is less than or equal to 2k. Okay, now the case 1 again. What is case 1? Case number 1. Okay, if x is greater than x naught, then integrating from x naught to x, we get what we get? Integration x naught to x u dash of x upon u of x dx is less than or equal to 2k into integration x naught to x into dx. Okay, here 2k is the constant. Here we get log of u of x. Okay, from x naught to x, which is less than or equal to 2k into in the bracket x of x naught to x. Okay, hence it implies that log of u of x minus log of u of x naught, which is equal to log of u of x upon u of x naught, which is less than or equal to 2k into x minus x naught. Okay, so which is equal to, which implies u of x upon u of x naught, which is less than or equal to what? E raised to 2k into x minus x naught, which implies that u of x is less than or equal to e raised to 2k into x minus x naught into u of x naught. Okay, any doubt?
No, sir.
But what is the u of x naught? Okay, what is u of x? Is norm of phi of x bracket square, which is less than or equal to k into x minus x naught into norm of phi of x naught. Okay, yeah, the get the letter. U of x is nothing but what? Wait a minute. Okay, starting again, u of x is nothing but what? U of x is nothing but what? Norm of phi of x, and u of x naught का एल मग norm of norm square of phi of x naught. Okay, hence putting this value here, we get this one. Okay, any doubt up to here?
No, sir.
So give it as an equation number 7. Now consider the left left side of inequality 6, we get similarly we get what we get e raised to minus k into x minus x naught into norm of phi of x naught, which is less than or equal to what norm of phi of x. Okay, any doubt? Give it
No, sir.
as an number 8. From 7 and 8 we can write, from 7 and 8 we get e raised to minus k to x minus x naught into norm of pi of x naught, which is less than or equal to norm of pi of x, which is less than or equal to, okay, e raised to k, okay, e raised to k into, ओके सॉरी, इथे काय येणार, स्क्वेअर रूट आहे ना, इथे स्क्वेअर आहे ना, पण टेकिंग स्क्वेअर रूट करा ह्याचं दोघांचं. ओके, स्क्वेअर रूट काढल्यानंतर हे येणार. ओके, तर स्क्वेअर रूट काढा ह्याचं दोन्हीचं. स्क्वेअर रूट काढल्यानंतर काय येईल, हे येईल. ओके, सिमिलरली for the left hand side of inequality 6 we get this one, and combining 7 and 8 we get e raised to k into x minus x naught into norm of phi of x naught. Okay, so this is the case 1. Now what is case 2? सेम प्रोसिजर आहे ती, त्या ठिकाणी जिथं बघितलंय तसंच इकडे वापरायचं. केस 2, इफ x naught is greater than x, then integrating from x to x naught, okay, we get e raised to minus k, okay, x naught minus x, similarly all the process is same, into norm of phi of x naught, okay, into which is less than or equal to norm of phi of x, which is less than or equal to e raised to k into x naught minus x into norm of phi of x naught. Okay, to give it as an equation number 9. Okay, so sorry, this is 9 and this is the 10th equation. So combining equation and 9 and 10 we get from equation 9 and 10 we get the required result. What is the required result? E raised to minus k into mod of x minus x naught into norm of phi of x naught is less than or equal to norm of phi of x, which is less than or equal to e raised to k into mod of x minus x naught into norm of phi of x naught. Okay, so this is the required result for the nth order homogeneous linear differential equation. Okay, any doubt up to here?
No, sir.
समजते?
Yes, sir.
फक्त calculation part आहे तिथे. Okay, so we proved that if let phi be the any solution of L of y, which is nth order homogeneous linear differential equation on an interval I containing the point x naught, then for all x belongs to I, this result holds, where k is equal to what? 1 plus a1 plus mod a1 plus up to so on mod an. And this is the phi of x. Okay? 8 ते 10 मार्काला हा क्वेश्चन तुमच्या सेमेस्टरला येऊ शकतो. Okay? So the next initial value problem for nth order. Okay, look at the definition of initial value problem for nth order. Look at it. The next point is initial value problem for nth order. Okay, now look at the definition. An initial value problem, initial value problem for L of y is equal to 0 is a problem is a problem of of finding a solution phi, okay, which which prescribed values of values for it and its derivative, its first n minus 1 derivative, okay, n minus 1 derivative, okay, at some point x naught, okay, which is initial point. तिकडे काय होतं, सेकंड ऑर्डर प्रॉब्लेम काय होता, सेकंड ऑर्डर असताना काय होणार, phi and phi dash, okay, 2 minus 1 first derivative, that is 2 minus 1 1. So first phi of x naught and phi dash of x naught देत होते तिकडे. Okay, so here the initial value problem for the nth order derivative, nth order, it means the initial condition काय असणार तिथे, phi of x, phi dash of x naught, phi of x naught, phi dash of x naught up to phi dash phi dash to n minus 1 x naught, हे तुम्हाला इनिशियल कंडिशन दिलेले असते. Okay, so this is the initial value problem for the nth order. Okay, suppose if alpha 1, alpha 2 up to so on alpha n are given n constant, okay, given n constant and x naught is some real number, some real number wait a minute, some real number, okay, then the problem of finding a solution phi of L of y is equal to 0, satisfying phi of x naught is equal to alpha phi dash of x naught is equal to, sorry, alpha 1 phi of x naught is equal to alpha 2, okay, phi double dash of x naught is equal to alpha 3 up to so on phi raised to n minus 1 of x naught, which is equal to alpha n. Okay, so these are the n initial conditions, okay, is denoted by, and finding the solution of phi of L of y satisfying this all these condition, and it is denoted by L of y is equal to 0, y of x naught is equal to alpha 1, y dash of x naught is equal to alpha 2 up to so on y raised to n minus 1 of x naught is equal to alpha n. Okay, so this is the initial value problem for the nth order. तिकडे सेकंड ऑर्डर असताना तुम्हाला दोन कंडिशन दिले होते, इथे nth ऑर्डर असताना n कंडिशन तुम्हाला दिले. Okay, so here x naught is the initial point of the interval. Okay, now the next point is, any doubt up to here? Any doubts?
No, sir.
Okay. Now the existence theorem for the initial value problem of order n. Existence theorem काय सांगतो की प्रत्येक इनिशियल व्हॅल्यू प्रॉब्लेमला तुम्हाला एक फाय असा सोल्युशन मिळतो की जे ते कंडिशन सॅटिस्फाय करतात, जे तुमचे n मायनस nth कंडिशन आहे अल्फा 1 अल्फा 2. जे जे डेरिव्हेटिव्ह आहेत की नाही हे सगळे कंडिशन सॅटिस्फाय करतो हा तुमचा थेरम सांगतोय एक्झिस्टंट थेरम फॉर द इनिशियल व्हॅल्यू प्रॉब्लेम ओके नाउ लुक ॲट हिअर existent theorem existence theorem for initial value problem okay or nth order way okay for the nth order initial value problem now look at the theorem let alpha 1 alpha 2 up to so on alpha n be any constant and for any real number for any real x naught there exist okay there exist is important एक तरी exist होतो there exists a solution phi of L of y is equal to 0 which is second nth order homogeneous linear differential equation on x running from minus infinity to x plus infinity okay it means x be the any real number satisfying satisfying phi of x naught is equal to alpha 1 phi dash of x naught is equal to alpha 2 up to so on phi dash of phi dash to n minus 1 x naught is equal to alpha n okay so this is the statement okay now look at the proof look at the proof let phi 1 phi 2 up to so on phi n be n linearly independent independent solution of L of y is equal to 0 okay on an interval I containing a point x naught okay so this is the assumption now we have to show that there are unique constant okay unique constant c1 and c1 c2 up to so on cn okay nth ऑर्डर असल्यामुळे किती कॉन्स्टंट दिली ते युनिक cn n कॉन्स्टंट such that such that such that pi of x is equal to what c1 pi 1 of x plus c2 pi 2 of x plus up to so on cn pi n of x okay give it as an equation number 1 satisfying initial condition satisfying initial condition phi of x naught is equal to alpha 1 phi dash of x naught is equal to alpha 2 up to so on phi raised to n minus 1 of x naught is equal to alpha n okay so we have to prove that we have to show that there exists a unique scalar c1 unique constant c1 c2 up to cn such that this condition holds okay phi of x is equal to c1 phi 1 c2 phi 2 up to cn phi n and satisfying this initial condition okay now differentiate equation 1 with respect to x n minus 1 times okay now look at here differentiate equation 1 with respect to x n minus 1 times. Okay, and substitute substitute x is equal to x naught, we get the system of equation as follows. ओके, आता तुमचा हा एक फर्स्ट इक्वेशन आहे. याला फर्स्ट डिफरन्शिएट केल्यानंतर काय येणार इकडे? फाय डॅश ऑफ एक्स इज इक्वल टू सी वन फाय वन डॅश सी टू फाय टू डॅश सी एन फाय एन डॅश ॲट एक्स नॉट. ओके, फर्स्ट डेरिव्हेटिव्ह. सेकंड डेरिव्हेटिव्ह काय येणार? फाय डबल डॅश ऑफ एक्स इज इक्वल टू सी वन फाय वन डबल डॅश सी टू फाय टू डबल डॅश अप टू सी एन फाय एन डबल डॅश ॲट पॉईंट एक्स नॉट. ओके, अप टू किती वेळा टाइम करायचे? एन मायनस वन टाइम्स. सो देर आर किती इक्वेशन येतील टोटल? टोटल किती इक्वेशन येतील? एन मायनस वन वेळा मी जर डिफरन्शिएट केला तर किती? ते एन मायनस वन आणि हा तुमचा ओरिजिनल आहे. एकूण किती इक्वेशन झाले?
n इक्वेशन.
एन इक्वेशन. आणि त्या इक्वेशनला मी सिस्टीम ऑफ इक्वेशन मध्ये लिहिलं. कसं लिहिणार? ॲज फॉलोज. लुक ॲट हिअर वी गेट phi 1 of x naught, phi 2 of x naught up to so on phi n of x naught. This is the first equation. And first we are differentiate केला काय ना? Phi 1 dash of x naught, phi 2 dash of x naught up to so on phi n dash of x naught. Up to so on शेवट पण काय येणार? शेवटची टर्म phi raised to n minus 1 phi 1 n phi 1 raised to n minus 1 x naught phi 2 raised to n minus 1 x naught up to so on phi n raised to n minus 1 x naught. Okay, so this is the system of equations. आणि इथे काय येणार तुमचा? हां, काय येणार?
C1 C2 up to Cn.
up to Cn. Okay, which is equal to, and right hand side काय येणार?
0.
नक्की?
Yes sir, homogeneous आहे.
phi of x naught काय येणार तुमचा? phi of x naught काय दिलंय?
No sir, alpha 1 alpha 2.
तेच म्हणतोय. फाय ऑफ एक्स नॉट काय दिलंय? अल्फा वन. फाय डॅश ऑफ एक्स नॉट काय दिलंय? अल्फा टू. ओके, तर इथे काय येणार? अल्फा वन अल्फा टू अप टू सो ऑन अल्फा एन. ओके, so this is the system of equation. Okay, now we know that phi 1 phi 2 up to so on phi n are linearly independent solution. Then by previous theorem त्यांचा तो स्किन काय असणार?
0.
थिरम रो स्किन ऑफ फाय वन. तिथे काय होता? दोघांचाच रो स्किन होता, फाय वन आणि फाय टू. इथे किती येणार? एनचा येणार. फाय वन फाय टू अप टू सो वन फाय एन of x naught at point x naught is not equal to 0. Why? Because all are linearly independent. Okay, that means determinant of this matrix, coefficient matrix, is not equal to काय येणार? 0 येणार. याचा डिटर्मिनंट जर नॉट इक्वल टू 0 आला तर काय होईल? द डिटर्मिनंट ऑफ कोएफिशिएंट मॅट्रिक्स इज नॉन झिरो. हेन्स द कोएफिशिएंट मॅट्रिक्स इज इनवर्टिबल. Hence the system possesses a unique solution, infinite solution, zero solution. What?
Unique solution.
युनिक सोल्युशन. इथे झिरो नाही आहे ना तुमचा, ट्रिवियल सोल्युशन येणार. ट्रिवियल असेल तर झिरो येणार. इथे अल्फा वन अल्फा टू असल्यामुळे काय होणार? युनिक सोल्युशन. ओके, सो हियर the row skein of phi 1 phi 2 up to phi n at point x naught is not equal to 0. Why? Because these are the solutions are linearly independent. We assumed that. ते assume केले ना? Phi 1 phi 2 phi n are the n linearly independent solution. Hence, the skin of phi 1, phi 2 up to phi n is not at point x naught is not equal to 0. That is, the determinant of coefficient matrix coefficient matrix is non-zero. Okay, then the coefficient matrix is invertible. The coefficient matrix is invertible. Okay, therefore the system possess a unique solution. म्हणजे तुमचे C1 C2 C3 up to Cn काय असणार हे युनिक असणार. Okay, by multiplying the inverse of coefficient matrix on both sides, we get unique values of C1 C2 up to so on Cn, satisfying the above system of equation. Above system of equation. Okay, thus every initial value problem has the solution. Okay, hence we proved that phi of x is, then this phi is also unique. Okay, so every initial value problem has a solution. Okay, any doubt?
No, sir.
त्यात कन्सेप्च्युअल पार्ट काहीच नाही आहे आपल्या डिफरन्शियल इक्वेशनमध्ये. जेवढं तुम्ही स्वतः सॉल्व्ह करताल, जेवढं तुम्ही स्वतः लिहून काढाल, तितकंच तुम्हाला सोपं जाईल. ओके, so this is the existence theorem for the initial value problem of order n, for order n. Now the uniqueness theorem for the initial value problem. Okay, काही डाऊट आहे का? काय स्पीड होते खूप
नाही सर.
आज दोन्ही
ठीक आहे.
लेक्चर आपले माझेच आहेत. ओके, so the next theorem is uniqueness theorem for initial value problem. एक्झिस्टन्स थेरम काय सांगतोय की एक ॲटलिस्ट एक तरी तुम्हाला सोल्युशन मिळेल. ओके, युनिकनेस थेरम काय सांगतोय ॲटमोस्ट एकच सोल्युशन मिळेल. ॲटमोस्ट म्हणजे आणि म्हणजेच काय, तो एकच आणि एकच असेल, एक आणि एकच असेल. ओके, नाउ लुक ॲट द थेरम. व्हॉट इज द स्टेटमेंट ऑफ दिस थेरम? Let alpha 1, alpha 2 up to so on alpha n be any n constant. Okay, be any n constants, and x naught be any real number. Okay, from an interval I, then there exists at most one solution phi. At most one solution phi. Sorry. Okay. At most one solution phi of L of y is equal to 0. Okay. Satisfying. That is fine. Phi of x naught is equal to alpha 1. Phi dash of x naught is equal to alpha 2 up to so on. Phi raised to n minus 1 of x naught is equal to alpha n. Okay. So this is the uniqueness theorem for the initial value problem. Okay. Now let's see the proof. Okay. Let L of y is equal to 0. Okay, and y of x naught is equal to alpha 1. Y of y dash of x naught is equal to alpha 2 up to so on. Y raised to n minus 1 up to x naught of x naught is equal to alpha n. Give it as an equation number 1. B. Give an initial value problem. Okay, now assume that phi and psi, okay, are the two solutions of initial value problem 1. Okay, this implies that L of psi, L of phi is equal to 0 and phi of x naught is equal to alpha n, and L of psi. If psi is the solution, then L of psi is equal to 0 and psi of x naught is equal to alpha 1. Psi dash of x naught is equal to alpha 2 to so on. Psi raised to n minus 1 of x naught is equal to alpha n. Why? Because we assumed that phi and psi are the solution of initial value problem 1. It implies that phi and psi satisfying all the given conditions. Okay, any doubt? आपल्याला
No, sir.
युनिकनेस प्रूव्ह करायचं आहे. याचा अर्थ काय करायचं, दोन घ्यायचे आणि ते एकच आहे असं सांगायचं. ओके, नाउ define theta is equal to phi minus psi. Okay, now consider L of theta is equal to L of phi minus psi. But L is linear differential of the term. It means we can write L of phi minus L of psi. But L of phi is what? 0. L of psi is what? 0, which is equal to 0. Okay. Now, it implies that theta is the solution of L of y is equal to 0. Now, theta of x naught is equal to, we get pi minus psi of x naught, which is equal to pi of x naught minus psi of x naught, which is equal to alpha 1 minus alpha 1, which is equal to what? 0. Similarly, we get similarly what we have, phi dash theta dash of x naught is equal to 0. Theta double dash of x naught is equal to 0 up to so on. Theta raised to n minus 1 of x naught is equal to 0. Okay, now we know that norm of theta of x naught is equal to the bracket mod of theta of x naught bracket square Okay, plus mod of theta dash of x naught bracket square up to so on plus mod of theta raised to n minus 1 of bracket x naught bracket square at whole bracket as theta is solution then by previous theorem we get what we get e raised to minus k into mod of x minus x naught into norm of theta of x naught which is less than or equal to norm of theta of x which is less than or equal to e raised to k into mod of x minus x naught into norm of theta of x naught. Okay, for all x belongs to I rationality. Okay, this x belongs to I, which implies that 0 which is less than or equal to norm of theta sorry इथे काय ना use this relation for the phi ना sorry इकडे तुम्हाला
थिटा
phi
यायला पाहिजे.
ओके काय थीटा येईल तिथे हो तेच म्हणते use this relation for the theta of x now okay norm of theta of x is less than or equal to norm of theta of x now okay here we get theta of 0 is less than or equal to norm of theta of x is less than or equal to 0 for all x belongs to what I which implies that norm of theta of x is equal to 0 for all x belongs to what I okay it means that हा तुमचा theta of x हा फंक्शन काय आहे त्याची लेंथ प्रत्येक x ला काय ते 0 येते इट मीन्स दॅट इट सेल्फ theta of x is equal to 0 function okay for all x belongs to I okay what it implies then theta is nothing but what phi of
फाय
x
मायनस साय.
psi of x sorry एक step ahead theta is nothing but what phi minus psi of x is equal to 0 as it is for all x belongs to I which implies theta phi of x minus psi of x is equal to 0 for all x belongs to I which implies theta of x phi of x sorry is equal to psi of x for all x belongs to I which implies that theta is equal to psi okay so this shows that every initial value problem has at most okay at most one solution okay so that is unique solution any doubt
नो सर.
तिथे सेकंड ऑर्डरसाठी प्रूव्ह केलं तर इथं फक्त nth ऑर्डरसाठी प्रूव्ह करायचं आहे तुम्हाला ओके सो दिस इज दी इनिशियल व्हॅल्यू प्रॉब्लेम फॉर दी nth ऑर्डर होमोजिनियस linear differential equation okay any doubt
नो सर.
घ्यायचं पुढचं थेरम ओके अजून एक थेरम घेऊयात मग थांबूयात ओके नेक्स्ट थेरम इज theorem now. Okay, next one, next theorem. Let phi 1, phi 2, up to so on, phi n be n solution of L of y is equal to 0 on an interval I, then prove that then prove that they are linearly independent linearly independent if and only if their Ruskin is not equal to 0 at point x is not equal to 0 on an interval I. करता येईल तुम्हाला प्रूफ का सॉल्व करू दे जसं सेकंड ऑर्डरचं प्रूव्ह केलं आहे तसंच nth ऑर्डरसाठी प्रूव्ह करायचं आपल्याला ओके येईल का करता का करू सोडून दाखवू ओके बघा आहात ना का झोपी गेलात सगळे
आहोत सर.
लेट phi 1 phi 2 up to so on phi n be n solution the n solutions of L of y is equal to 0 okay on an interval I. Okay, now suppose assume the first part if rho skin of theta 1 phi 1 phi 2 up to phi n at point x is not equal to 0 for all x belongs to I. Okay, let c1 c2 up to so on cn be any n constant okay such that c1 phi 1 of x plus c2 phi 2 of x plus up to so on cn phi n of x is equal to 0 for all x belongs to I. We have to prove that these are the LOL linearly independent solution. Linearly independent प्रूव्ह करण्यासाठी काय करावं लागेल मला सगळे C1 C2 अप टू Cn काय इज इक्वल टू 0 आहे हे मला प्रूव्ह करावं लागेल ओके so give it as an equation number no, equation number sorry now on differentiating with above equation n minus 1 times we get system of equation as follows okay so here we write phi 1 of x phi 2 of x up to so on what is phi n of x here the phi 1 dash of x phi 2 dash of x up to so on phi n dash of x up to so on here phi raised to n minus 1 of x sorry phi 1 raised to phi 2 raised to n minus 1 of x up to so on phi n raised to n minus 1 of x okay so this is the system of equation we can write like this okay the coefficients are c1 c2 up to so on cn okay which is equal to right hand side काय येणार राईट हँड साईड काय येणार काय राईट हँड साईडला काय इक्वेशनच्या राईट हँड साईडला काय येते आहात का झोपी गेलात
0.
0 0 up to so on this is 0 okay so we have what we have row skin of phi 1 phi 2 up to so on phi n at point x is not equal to 0 for all x belongs to I. Okay, that is the determinant of coefficient matrix. Coefficient matrix is non-zero, non-zero. Therefore, the system possess possess
Trivial solution.
trivial solution. Trivial solution. That is, C1 is equal to C2 is equal to up to so on is equal to Cn which is equal to 0. Okay. Therefore, the coefficient matrix is invertible. On multiplying by the inverse of coefficient matrix on the both sides, we get C1, C2 up to Cn is equal to 0. Therefore, the solution phi 1, phi 2 up to so on this phi n are linearly independent on I. Okay, any doubt?
No, sir.
Now, the converse part is the converse. Conversely, assume that assume that phi 1, phi 2 up to so on phi n are linearly independent on I. Okay, to prove that row scheme of phi 1, phi 2 up to so on phi n at point x is not equal to 0 for all x belongs to I. Okay, for all x belongs to I हे आपल्याला प्रूव्ह करायचं आहे. सपोज इफ पॉसिबल कॉन्ट्रडिक्शन अजून करायचं इफ पॉसिबल काहीतरी पॉसिबल करायचं देर एक्झिस्ट एक्स नॉट ॲट पॉईंट आय इन बिटवीन आय देर एक्झिस्ट अ पॉईंट एक्स नॉट बिलॉंग्स टू आय सच दॅट रोस्किन ऑफ फाय 1 फाय 2 अप टू फाय एन ॲट पॉईंट एक्स नॉट इज इक्वल टू 0 असं ॲझ्युम केल्यानंतर कुठेतरी आपल्याला कॉन्ट्रडिक्शन मिळेल. ओके, इफ पॉसिबल let us assume that the contradiction that there exists a point x naught belongs to I. Okay, such that row scheme of phi 1, phi 2 up to so on phi n at point x naught is equal to 0. Okay, so substituting equation x is equal to x naught, substitute x is equal to x naught in above system. Okay, we get what we get here. We get phi of x naught, phi 1 of x naught, phi 2 of x naught, up to so on phi n of x naught, phi 1 dash of x naught, phi 2 dash of x naught, up to phi n dash of x naught, up to so on here. What we get last term? Phi 1 n minus 1 x naught, phi 2 raised to n minus 2. ओके, एनी डाऊट? काही डाऊट आहेत का?
No, sir.
हां, डाऊट असतील तर विचारू शकता तेव्हाच्या तेव्हाच. Okay, wait for me. Hmm. So this is the system of equations. Okay. So since the determinant of the coefficient matrix is equal to 0, here we assumed that row skin of phi 1, phi 2 up to phi n at point x naught is equal to 0. It means that ह्याचा determinant काय झाला? Equal to 0 झाला. Equal to 0, 0 झाल्यानंतर काय होणार? The system has a non-trivial solution. Okay, that is at least one of Ci is non-zero. Okay, now look at him. Since the determinant of coefficient matrix, that is row skin of phi 1, phi 2 up to so on phi n at point x naught is equal to 0. Therefore, the system the system has what? Non-trivial solution. कसं काय नॉन ट्रिवियल सोल्युशन येणार? जर डिटर्मिनंट 0 झाला तर तुमची रँक काय येणार ह्याची? लेस दॅन एन येणार. हा एन क्रॉस एनचा ऑर्डरचा आहे ना, मग रँक काय येणार? लेस दॅन एन येणार. मग जेव्हा
Less
तुम्ही
than n.
C1 C2 चे काय येतील? नॉन ट्रिवियल सोल्युशन येतील. ओके, the system has a non-trivial solution, that is at least one of C1, C2 up to so on Cn is non-zero. Okay, now consider a function. What is the function? Psi of x is equal to C1 phi 1 of x plus C2 phi 2 of x plus up to so on Cn phi n of x. Okay, for all x belongs to I. Consider the psi of easily seen that if psi is the function, then L of psi is equal to 0. Okay, and psi of x naught is equal to 0. Psi dash of x naught is equal to again 0 up to so on psi raised to n minus 1 at point x naught is equal to 0. Okay, any doubt? Okay, psi हा तुमचा एक फंक्शन घेतलाय c1 phi 1 c2 phi 2 up to cn phi m. Okay, if this is the solution of L of y, then it means that L of psi is equal to 0 and it satisfies the condition, given condition. Psi of x naught is equal to 0, psi dash of x naught is equal to 0 up to psi raised to n minus 1 of x naught is equal to 0. Okay, hence we know that norm of psi of x naught is equal to mod of the bracket, okay, psi 1 of x naught, sorry, psi of x naught bracket square plus mod of psi dash of x naught bracket square up to so on plus psi raised to n minus 1 at point x naught, which is bracket square and whole bracket raised to 1 by 2. Okay, which is equal to 0 by using all these values. Okay, for norm of psi of x naught for all, sorry, the x naught is belongs to I. Okay, so as psi is the solution, psi is this. What we have? Norm of psi of x naught into e raised to what? Minus k mod x minus x naught, which is less than or equal to norm of psi of x, which is less than or equal to norm of psi of x naught into e raised to k into norm mod of x minus x naught, which is less than the zero to another zero by putting the value of psi of x naught. Hence, for all x belongs to I here. Okay, for all x belongs to I. High x का असणार for any x, which implies that norm of psi of x is equal to 0 for all x belongs to I. It implies that psi of x is itself a 0. Okay, for all x belongs to I. Okay, but what is the psi of x? What is psi of x? C1 phi 1 of x plus C2 phi 2 of x plus up to so on. Cn phi n of x is equal to 0 for all x belongs to I. Okay, what is psi of x? तुमचं psi काय इथे? Okay, we consider the function. Okay, so this is 0 for all x belongs to I, where आधी काय प्रूव्ह केलं आपण? Where at least one C1, C2, one of C1, C2 up to Cn is non-zero. Okay, which implies that phi 1, phi 2, up to so on phi n are linearly what?
Dependent.
Dependent. Okay, so which is contradiction to our assumption, which is contradiction to our assumption. Okay, what is our assumption? Phi 1, phi 2 up to so on phi n are linearly independent. Okay, this contradicts arises. हे कशामुळे येते? This contradiction arises due to wrong assumption. Due to wrong assumption. Okay, what is our assumption? There exists point x naught. So this is the wrong assumption. Hence, we must have at phi 1, phi 2 up to phi n at point x naught is equal to 0 is wrong. We must have is not equal to 0. Hence, we must have row skin of phi 1, phi 2 up to so on phi n is of x at point x is not equal to 0 for all x belongs to I. Okay, hence the proof. Any doubt? कळते ना काय चालू आहे? फक्त मी एकदा
हो
हो.
सर.
काही नाही, तिथं फक्त तेच आपण सेकंड ऑर्डरला केलं होतं तेच आपल्याला इथे nth ऑर्डरला करायचंय. ओके, एनी डाऊट अप टू हिअर?
नो सर.
लिहून घेते का नाही?
Yes,
घेतोय
sir.
सर.
ओके, घ्यायचं नेक्स्ट थरम.
सर लास्ट स्टेपच्या सेकंड लास्ट स्टेप मध्ये तिथं नॉट इक्वल टू झिरो पाहिजे ना
इथे का?
एक्स नॉट पॉईंट साठी हा
हां, तेच सांगतोय तुम्हाला, लक्ष द्यायचं. C1 phi 1 of x, C2 phi 2 of x, and up to Cn phi n of x is equal to 0 for all x belongs to I, where we prove that at least one of C1, C2, okay, is non-zero. It means what is it means? If all these phi 1, phi 2 up to phi n are linearly dependent येत आहे. कशामुळे डिपेंडेंट येत आहेत? विच इज कॉन्ट्रडिक्शन टू अवर अझम्पशन. आपण अझम्पशन काय केलंय कॉन्व्हर्स पार्ट मध्ये? इथे assume that phi 1 phi 2 are up to phi n are linearly independent. हे assumption केलंय. ह्याला इथे कॉन्ट्रडिक्शन मिळतंय. कुठे? Look at here. Which is contradiction to our assumption phi 1 phi 2 up to phi n are linearly independent. ही कॉन्ट्रडिक्शन कशामुळे येतोय? Due to our wrong assumption. What is wrong assumption? There exists a point such that x naught belongs to I. Rho skin of phi 1 phi 2 at point x naught is not equal to 0. Okay.
इक्वल टू झिरो आहे सर.
Wait. ते इक्वल नाही, हे बरोबर आहे. धिस कॉन्ट्रडिक्शन ड्यू टू अरायझेस दिस कॉन्ट्रडिक्शन अरायझेस ड्यू टू रॉंग अझम्पशन. हेन्स हा तुमचा रोस्किन आहे ऍट पॉईंट एक्स नॉटला, तो झिरो नसून काय असायला पाहिजे? नॉट इक्वल टू झिरोच असायला पाहिजे. करेक्ट आहे. ओके, म्हणजे हे दिलेलं स्टेटमेंट करेक्ट असायला पाहिजे. ओके, हे रॉंग आहे, आपण
ओके
जे
सर.
अझम्पशन केलंय. ओके,
हां
म्हणजे या पॉइंटलाही तो झिरो नाहीये असं सांगितलंय. म्हणून एक्स नॉटला पण झिरो नाहीये, म्हणून काय केलंय? हेन्स वी मस्ट हॅव फॉर ऑल एक्स द रोस्किन इज नॉट इक्वल टू झिरो. ओके, हे संपला स्टेटमेंट इथेच. हा स्टेटमेंट संपलाय तुमच्या इथेच. इथून इथे नवीन स्टेटमेंट पुन्हा. ओके, एनी डाऊट?
नो सर.
म्हणजे इथे इक्वल टू झिरो हे रॉंग आहे, म्हणून काय येतोय? तिथे पण तो नॉट इक्वल टू झिरो असायला हवा. म्हणून ऍट ओके इथे फॉर ऑल एक्स नाही येणार. ओके, या पॉइंटला नाही, म्हणून तो काय झाला? प्रत्येकाकडे तो नॉट इक्वल टू झिरो झाला. ओके, एनी डाऊट अप टू हिअर?
नो सर.
ओके, नेक्स्ट थेरम घ्यायचा. 3 पानाचा थेरम आहे, अजून एक मोठा. ओके, फक्त स्टेटमेंट बघूयात, त्यानंतर थांबूयात. ओके, स्टेटमेंट घेऊयात. लुक ॲट दी नेक्स्ट थेरम. Let phi 1 phi 2 up to so on phi n, okay, the n n solution solutions of del of y is equal to 0 on an interval I, okay, containing sorry containing a point x naught, containing point x naught, then prove that row scheme of phi 1 phi 2 up to so on phi n at point x is equal to, okay, नीट लक्ष द्या, कोणी खाली व्यवस्थित. Then prove that row skin of phi 1 phi 2 up to so on phi n at point x is equal to e raised to minus a1, okay, into x minus x naught. into row skin of phi 1, phi 2 up to so on phi n at point x naught. Okay, so this is the theorem we have to prove. Okay, let phi 1, phi 2 and phi n are the n solutions of L of y is equal to 0 on an interval I containing a point x naught. Then prove that the row skin of phi 1, phi 2 up to phi n at point x is equal to e raised to minus a1. Okay, e raised to minus a1 into x minus x naught into row skin of phi 1, phi 2 up to phi n at point x naught. इथे x आहे आणि इकडे x naught आहे, नीट लक्ष द्या. आणि हा तुमचा a1 काय, कोएफिशियंट ऑफ nth ऑर्डरचा काय असणार, एल ऑफ वाय काय आहे तुमचा, एल ऑफ काय, एल ऑफ वाय वेअर लिहून ठेवा. हा स्टेटमेंटचा पार्ट नाही आहे पण लक्षात असू दे. एल ऑफ वाय काय तुमचा, वाय रेस टू एन प्लस a1 y raised to n minus 1, okay, plus a2 y raised to n minus 2 up to so on an y is equal to 0 है ना. हा तुमचा जो कोएफिशिएंट आहे a1. ओके ओके कळते. सो दिस इज द थेरम. प्रूफ करायचं का का थांबायचं, काय करायचं सांगा पटकन, थांबूयात.
हो सर.
ओके, कंटाळत असाल तुम्ही आता 2 तास सलग असल्यामुळे. ओके, तर थांबूयात आपण इथे. त्या थेरमचं प्रूफ आपण नेक्स्ट लेक्चरला बघूया. ओके, एनी डाऊट अप टू हिअर. त्याच्यानंतर मग एक्झाम्पल करतो. ओके, या थेरम नंतर तुम्हाला एक्झाम्पल येतील. ओके, एनी डाऊट अप टू हिअर.
नो सर.
ओके, सो वेट अ मिनिट. प्रेझेंटी कमी दिसते, जर हळूहळू कमी होते वाटतं 3:30च्या लेक्चरला. Wait a minute.